Hello everyone, thank you for joining me for this video. Today I'm going to discuss the convolution and I'm convolving two signals and then plot them in MATLAB. But before I use MATLAB, I'll go over the concept and show how you can calculate the convolution. But what is a convolution? Convolution is a very important topic in digital signal processing, and pretty much we use it in a lot of areas like audio processing, speech enhancement, image processing, communications, and even machine learning. And so we are using in a variety of areas, and basically what it's doing is filtering, smoothing, or we use it in moving average. All right, so now let's see how we can what is convolution. All right, so in this video, let's say we have two signals, h of n and x of n. Basically, and you, I'm sure you have seen this this sign here. This is not multiplication. This is a convolution in digital signal processing, and you are not multiplying. So just make sure you are aware of this is not a multiplication. This is called convolution sign. All right, so what is convolution in a real application, or what is the intuition of convolution? So in convolution, when we convolving two signals, basically what we do, we are flipping one signal over the y-axis and slide it over the other one. Let me grab. So I draw h of n and I flipped it. So when we so it's flipped, and then we slide it over the other signal. In our case is x of n. So convolution is flipping one signal over y-axis and sliding over the other one. And when we sliding, we multiplying. So let's say we are sliding, so we are multiplying sample by sample and adding them together, and we keep doing it until we completely cover the other signal. And when you see here there is no cover, so yeah, this is how we do convolution. But now let's see how we can do this by an example. All right, so let's see. So here, let's see, you have two signals. All right. Let's say you have x of n and we have h of n. So x of n is, let's say, 1, 2, 3, 4, 5. And let's say, so when you see this arrow in this context, that means this is a zero indexing. 0, 1, 2, 3, 4. And for the h of n, let's say we have negative 1, 2. Let me write it nicely. Negative 1, 2, and 1. And let's say here we have zero indexing is at 2. Let's say 0. No, this is a negative 1, 0, 1. All right, so how we calculate convolution is we write them this way. So 1, 2, 3, 4, 5, and negative 1, 2, and 1. So we do 1 to 1 is negative 1, 2, 3, negative 4, negative 5. What I'm doing is I'm basically multiplying this to each individual. Negative 1 times 1 times 2 times 3 times 4 times 5. All right. So for the next sample, we slide our we slided one sample to the right. So we start from here. This is very important. So, and then we multiply this sample to individual of the x of n. So it's 1 times 1, 2 times 1, 2 times 2, 2 times 3, 2 times 4, and so on. And same thing for the next one. We slided once one sample, and we multiply 1 to each individual. So we have 1, 2, 3, 4, and so now we simply add them together. So here we have negative 1, 0, 2, 4, 6, 14, and 5. Basically what I did is, if I draw the line here, then you can see it much better. All right, so this is our result. So now the question is, how is our indexing? So where is our 0 index, 1, 2, 3, and so on? So this is how you do the indexing. So you count from here. I don't know if you see. Hope you see. Let's see. Hopefully you see my arrow here. So you start from here, and 1, 2, 3, 4, and 5. If you look here, I counted the 0 position. For the next one, I'm not counting the 0 position. So, and just only the first one. And when we reach to the 0, I'm not counting the 0. So how many samples we have? 1, 2, 3, 4, 5, 6. So now I come here and I say, okay, 1, 2, 3, 4, 5, and 6. This is my 0 position. This is 0. Let's see, this is 0, 1, 2, 3, 4, 5, and this one is negative 1. This is how you calculate the convolution and make sure the indexing look like. And one more important thing is here is when you have, let's say, so if you look at the signal, how many elements do we have? 1, 2, 3, 4, 5. So we have 5 in element in our x of n, and we have 1, 2, 3. So the total of our convolution should be m plus n. Okay, so no, this is not good. Let me write it this way. M plus n minus 1. M is the element of x of n, and n is the element of the number of elements in a h. So here we have 3 minus 1 equals to, let's see, equals to 7. So if you see here, we have 1, 2, 3, 4. If you here, I'm not sure you can see it. So 1, 2, 3, 4, 5, 6, 7. We have 7 elements or 7 samples in our convolution. So, and this is a very important point for calculating convolution. M plus n minus 1. All right, so now let's see how we can do exactly the same thing in MATLAB. And I'm using a built-in function in MATLAB, and so pretty much easy. Just showing there is a function in MATLAB that you can use either to use in your project or check your answer. So here, let's say we have x equals to 1, 2, 3, 4, 5, and h equals to -1, 2, 1, and I use a y variable, and conv is the function for convolution, and I use x and h and run it. Let me to see the result. Yeah, as you see here, we got the same exactly result by calculating by hand, and the MATLAB function gave us the same result too. So I think that's all for today. See you in the next video. Thank you.